we're just trying to do a better job at improving our programs, but also trying to move into predictive analytics and making business decisions based on what data trends show. So I need to get smart on data analytics.
Okay. Well, this is a good place to start getting smart. I don't know that it's the end of the road at all. It's a great big world out there.
Well, I have nothing else as of right now, so I'm happy with this.
Okay, Andra, welcome. Go ahead, Thomas.
All right. My name's Thomas Lavender. As far as hobbies go, I have 2 children and a wife, so hobbies kind of went the way of the dodo. Right now I currently work with the Arkansas Heart Hospital. I've been here about a week. Before that, I worked mostly in the IT field, but my experience was pretty much tailored to the company I worked for. I worked for Stevens Inc. for about 17 years, and I was pretty tailored to their system. So my actual expertise in IT is somewhat limited, which kind of leads me to this. I'm trying to get a better grounding. Plus, like I said, I was there for about 17 years and they were running a pretty dated system. So as you can imagine, my skills as far as new tech got a little dated as well. So I'm trying to kind of catch up to where everything is now and just kind of get a firm foundation. I did 2 years of Pulaski Tech. That's about the extent of it. I'm kind of weighing my options to continue where the direction to continue anyway. So yeah, that's about it for me.
Okay, thanks, Thomas. Welcome. Brittany.
Hey there. So Brittany Tomshow. I also work for Waco. So I work with Gabe and Chase and Alex, not Alex, Aaron. Sorry. We just added a bunch of A members to our team. Aaron and Priyanka. I have been in the publishing industry since I graduated college in 2010. I pretty much have worked in every department or been a manager in every department in the publishing industry, except for editorial. And I just work cross-department with our editorial teams. Now in my role, I am the subscriber retention manager for Waco Media, and I've been doing that since about January, but worked for one of our local markets prior to that. My hobby is my husband is an engineer in the military, so we get to travel a lot. So that is probably my biggest hobby is traveling and running. And I also have a 4-year-old daughter. She just turned 4 yesterday, so she takes up a lot of my time. Let's see, expectations for this course. So I really think for this course, we have a data analytics team, which is Aaron and Priyanka. And so I'm just hoping to gain some skills to help them out as we are setting up new processes, reconciling and presenting data to our executive leadership. And so any skills I can have or can gain to add to that and to make things run more seamlessly for Waco.
Okay, good deal. Welcome, Brittany. Damon, good morning.
Hey, good morning. So my name is Damon Perez. I work at Arkansas Blue Cross Blue Shield. Hobbies, I guess drawing would be my only real hobby I do pretty often. Duties at Arkansas Blue Cross Blue Shield. I am a business analyst, so mostly using R and Excel to kind of manipulate the data and kind of draw some conclusions from that. I went to the University of Arkansas at Fayetteville. My bachelor's was in industrial engineering. My minor was in data analytics, and I got a supply chain emphasis. I'm hoping to get a better understanding of data analytics beyond what my minor provided me. Taking 5 or so classes at a time, it was kind of hard to really absorb a lot of the data analytics information. So I'm hoping this can kind of buff me up in that kind of respect.
Okay, Damon. Well, welcome. So you are doing some R programming now. Is that pretty extensive, or just like quick graphing projects? Or?
No, I'd say it's somewhat expensive. I spend at least half of my time in R, just going through the data, changing tables around and whatnot.
Okay, well, you're going to hate this because we're using Python. So there's just those minor changes. It helps to have either one or the other, but Python and R are these two competing. It's like Microsoft and Apple, these two competing technologies in data analytics. So I'll I'll forgive you in advance if you get frustrated with Python, because I know it's tough to learn more than one or work with more than one sequence. Anyway, welcome, Damon. Lindsay?
I appreciate it.
Hi, my name is Lindsay. I work in cybersecurity at GSK, and hobbies, taxidermy and thrift shopping. And I'm just hoping to learn how to, I need to make executive dashboards and stuff like that. So I just need to learn how to turn data into pictures and stuff like that. And that's it.
Okay, well, welcome, Lindsay. We've got a particularly skillful guest speaker coming up in a month or so, Mr. Bill Shander. He's the one of the major providers on LinkedIn Learning or lynda.com when it comes to data visualization and data storytelling. He actually comes from a psychiatry background, or psychology background. So that'll be a good part. And then, yeah, we'll be doing Power BI dashboards towards the end of the course. So welcome, Lindsay.
Thank you.
Erica?
Hey everyone, I'm Erica. I also work at GSK in cybersecurity. I'm a cyber intelligence analyst. I have a degree in network technology. I've been at GSK for about 8 months or so. I am hoping to, I have no experience with data analytics or programming languages in general. So I'm just really hoping to, I do a lot of research and work with a lot of data. So I'm just hoping to be able to organize and kind of, organize data and just learn as much as I can. My hobbies, I have 3 children and they're pretty active in sports. So my hobbies pretty much revolve around their hobbies. And that's it for me.
Okay, welcome, Erica. And for everybody, everybody's knowledge, Lindsay and Erica work at a company that had attendees in the last cohort that we did last summer, same as I believe Chaz and Andra have some coworkers that have also worked with me. So they had fair warning and they still came in. So nothing. Nothing I can do about that. All right. Welcome, Erica. Hey, Priyanka, go ahead.
Hi everyone, I'm Priyanka Chutke. I'm currently working as analytics manager with Waco, and Brittany and Aaron are my teammates. So currently, I'm also pursuing my master's in business analytics at University of North Texas. I'll be graduating on May 1st. Prior to this master's, I pursued MBA in finance. That was in India. I moved to the States in April 2019. And currently my hobbies include playing table tennis, and I love watching multilingual movies, be it Spanish, French, English, and I'm from India, so there are multiple languages in India. And I also love playing table tennis. My expectation from this course is when I looked at the curriculum, I see there are a couple of topics which were untouched here at university. So I'm glad I'm part of this program and I'll be able to learn more and simultaneously implement with my team members. Thank you.
Okay, well, welcome, Priyanka. And I know you're in a leadership role, so hopefully we will touch on things not just at the lowest level, tactical, technical level, but also at the team, organizational process level that might help foster some thought in a data analytics working group or data analytics team. So, and welcome. And it's great to have, like I said, it's great to have people from at different experience levels come into the course. So we will move on to Chaz.
Hi, I am Chastity is what I've got here, but yeah, everyone calls me Chaz, Chastity, kind of like Gabe. It just depends on who's talking to me at the time. I am working with CAE. I work with Anja, and I am on the instructional design team with CAE. And my background is with the military training at the KC-135 program, which is in Oklahoma. And as an instructional designer, when it comes to data analytics, it's all centered around, students and grades and critiques and things like that. And only recently have I moved to Arkansas to be part of the CAE team here, and have become part of a working group, a data analytics working group, which is kind of my first exposure to the level of analysis that they're doing. So this class, I really am looking forward to learning some tricks of the trade so that I can really bring some more dynamics to that group and help support the team there. I have some familiarity with SQL based on my past experience at the 135 program, and but Python will be a new experience for me. So I enjoy coding, so I will hopefully pick this up and enjoy learning that new syntax too. As far as education, I have my degree is in instructional design. I haven't had a lot of data science or data analytics formal training like most of you folks have had, but I look forward to learning from y'all. And my hobbies, I have like a ton of kids, and this summer it's all about camping and going out and enjoying Arkansas, learning about this new state we're in. So that's my current hobby.
Okay, good deal. Welcome, Chaz. And Aaron, good morning.
I'm Aaron. I'm also working at Waco Media with Priyanka and Brittany and Chase and Gabe. As far as hobbies go, it's kind of the same as others have mentioned. I have a 1-year-old. She takes up a lot of my time. Before she came along, I was really into hiking and running and anything outdoors. I spend probably 50% of my workday in our customer data platform doing a lot of marketing related tasks and about half my day in analytics. But as we've grown our team, I'm hoping to spend my full day in data analytics. And so hoping this course, I can learn a bit more about data science. I'm excited to learn about Python. And I'm also interested in predictive analysis so that we can better understand our site traffic and their propensity to subscribe.
Okay, good morning. Thank you, Aaron. I've got a little bit of experience when I was running the Arkansas Coding Academy at UCA. We had a social media campaign going, and I'm not a marketing guy at all, but we had an advertising firm that would tell us all of the all of the terminology that's probably second nature to some of you guys. The impressions and first clicks and looks and unique visits and all of those sorts of things that you want to know about with social media. So yeah, incredible. I think it was the Google Analytics platform that provided most of that information. So welcome, Aaron.
Hey, Don.
Hey,
Don,
yep.
you know, I'm going to jump here, but
Oh.
I just wanted to say that having heard the richness of this group and all the different companies that they're from and such a varied set of backgrounds and experiences and some overlap in what their expectations are, but also some things that are pretty specific. And I think that's just going to be fantastic to see how that plays out here. And so everything that I said up front about encouraging you, I'm also equally as excited as you are. I do see that our PMO director, Marie Stacks, has joined us. Marie, are you here? Did you want to kind of chime in and share some things with this group here from a kind of PMO perspective? I know Kelsey's been reaching out to a lot of them, but I just noticed you had joined and wanted to see if you wanted to say a few words.
Absolutely. Thanks, Lonnie. So hi guys, I'm Marie Stacks. As Lonnie mentioned, Director of Operations. It's great to see all you guys in the class and definitely excited that you guys are here. So if you have not completed your paperwork, please do so today. Otherwise, you probably won't be in next week or in the next class until you complete it. So if we can get that done, that would actually make a world of difference for the PMO team and definitely a world of difference in what you're doing today. So let us know if you have any questions on that. Kelsey is a fantastic contact for that. I'm sure she's already been in touch if there is anything outstanding. So please definitely send us your questions. But yeah, glad to have you guys here. I know you're in good hands with Don. He's a lot of fun. The last cohort definitely had fantastic things to say. So you will be spoiled and well taken care of.
No pressure. Okay. Lonnie, did you want to say any final words and
No,
hop off? Or okay.
I'm going to jump off, but I just want to say, hope everybody has a great experience. And as Marie have mentioned, we're always here. So we'll be talking with your company reps and folks that we've already interfaced with. That's kind of my role, working with all of the employers around the state. So we always want to hear from you, and Don will keep us informed. And Don, we'll probably stop in every now and then on some of these sessions just to kind of say hey and see how it's going. And when we used to meet face to face, we do some lunches every now and then. But since we're not kind of doing that right now, we miss some of that. But
it's coming back. I get my first shot on Thursday afternoon at the VA clinic up there in Conway. I'm really looking forward to the whole post-COVID, fully vaccinated, no masks. Oh my goodness, what a year it's been. All right, well, thanks, Lonnie. And yeah, you're welcome anytime. As you know, Lonnie's kind of like my boss's co-boss, my deputy boss. At ACDS.
Thanks
All right,
again.
Lonnie.
I'll see y'all soon. Okay.
Okay.
Bye-bye.
Thanks, Lonnie. And Marie, do you want to hang out for a little bit, or?
Yes, I think I'll hang out for just a minute, but I will drop off and no one will notice, I promise.
Okay. Well, it's my turn. I get to talk about myself a little bit. Guys, I'm Don Walker. Professionally, I joined the Air Force right out of high school back in '82 and was an electronics technician on initially C-130s here at the base in Jacksonville, Arkansas. I met my wife, got married, and we moved to Guam and then Texas and New Mexico and California and Japan and Virginia and Kansas, and finally ended up back in Florida where I retired after 30 years. So my work experience is almost entirely in the military or higher education. I've been adjunct faculty, started out with University of Phoenix. I've done some work with a couple of other colleges. So I've got a heavy background in the military and higher ed. After electronics, after 6 years, I got tired of carrying a toolbox and getting rained on and snowed on, because they don't pull a C-130 into a hangar when it's cold outside. You work outside. So I got tired of that. And this guy I was working with had been approved for cross training into computer programming. And this is 1988. 87 actually, and I was like, computer programming, what's that? I mean, I played some games on a Commodore 64, but not too many people had a computer at home. So I learned a little bit more about that, applied and got accepted to cross train into programming. Worked with Oracle relational databases quite a bit. For the next 6 years, my biggest project was putting the first computer and database application on Air Force recruiters' desks so that when they're talking to somebody that wants to join the military, they would actually gather all that data and then print out the forms electronically versus using an IBM Selectric typewriter and carbon paper forms. So I designed and fielded that system with a couple of other guys. Finished a degree in management information systems. Didn't graduate till I was 30. Non-traditional student. 30 years old, E5 in the military with 3 kids when I finally graduated. But I got picked up for officer training school. Moved into software engineering, a little bit more on the process side of things versus being on the keyboard, and system testing. Moved into telecommunications and network management. The military made a decision that their uniformed folks shouldn't be writing software. We probably weren't going to run out of the back of a C-130 in the desert and start coding Java or, but we might set up tactical communications equipment, or very likely. So that's what I moved into was basically setting up and running core services, internet, file print, storage area network, that sort of stuff. Then kind of moved into a couple of different jobs at the enterprise information systems level. During that time when they switched over to the emphasis away from software development and towards the network, I got a master's degree in telecommunications from Southern Methodist University, and then finished out my career. Went on a break. I was a college professor, retired lieutenant colonel, in 2012. Took a break. My wife and I bought a motorhome and traveled. I mean, I would teach classes, but I took a break to figure out what I wanted to do next. I had a great luxury, so we traveled we did Alaska and Newfoundland, and we'd go to Washington or Vermont or whatever, anywhere in the summer to get out of the heat, and then back to Tampa, where I finished my military career. We'd go back to Tampa for the winter in a motorhome full time for 7 years. But like I said, I met my wife when I was here in Jacksonville, Arkansas. She's from North Little Rock, and we always came back home. I'm a gypsy from a family of gypsies, vagabonds, military brat, 3rd generation military brat. So we didn't have location roots anywhere near like you native Arkansans may not realize just how deep the roots go, but my wife's home back here in North Little Rock was always where we knew we would settle. So a couple years ago, her mother started needing help, and my mother's 87 and is going to be needing help soon. So we came off the road and went back to work. And during the last 3 years I was on that road trip, I finished a doctorate in computer science, all online, using my GI Bill. So that's my background, very broad in IT. I call it a mile wide and an inch deep. I've been an analyst, I've been a database developer, I've been a software engineer, coder, a tester, network control center chief, integrations lab chief. So I've been exposed to a lot of that stuff. But I'm not a working analyst day in, day out. So I'm envious of you guys for getting to dig into the tools and being at that place in your career where you get to really focus on the technologies. So I bring in, you'll notice I bring in guest speakers when it's time for someone to give a current industry perspective and do a little bit more advanced, whether that's SQL, advanced SQL, or some data analysis with Python, or like I said, I've got Mr. Shander coming in for data storytelling, data visualization. But I'll get you through the basics, and then I'll bring in guest speakers as necessary. So that's me and my background. I wanted to go to the next slide if I can. Okay. Go to course objectives. Okay. We'll talk about general in data in general, the different formats and sources. And again, this is all focused on less on theory and industry in general, and more on your particular organizations. So we'll learn about the data analytics lifecycle and actually do a couple of projects. A few projects that follow that full life cycle. Learn a little bit about statistics. It's not absolutely necessary to apply advanced statistics to data analysis, like it is maybe in clinical research and some of those areas, but we will cover that sort of stuff. We'll do some Excel, data wrangling, data accessing, formulas and charts and whatnot. Although we won't go heavily in depth into Excel, other than to use it for your personal use as an analyst, as opposed to publishing a full, like an application in Excel. I'll cover the design and implementation of relational databases. There's a particular way that they're called tables in a relational database are laid out, and then the language. Pretty much the only technology that I learned in 1988 that is still absolutely with us entirely today is structured query language, SQL. It's an ANSI standard that is used in every area of information technology, web development and finance, and your Google queries, everything. A lot of things are stored in relational databases from companies like Oracle. Microsoft makes SQL Server, so we'll cover that to the point where you can access data and answer questions with it. We'll learn data storytelling and the importance of different aspects of data storytelling and the reporting part of data analytics. We'll go into Power BI to a introductory, semi-intermediate level. None of these topics are meant to be an absolute mastery, but they'll certainly get you going to where you can finish out what you might need for your work in those tools. I'll start from scratch with Python. Some of you haven't coded at all, so yay! I get to teach programming from a software developer, software engineer's standpoint, and hopefully you'll understand more than just running analytics with Python, because that's one line of code, but actually automating something, which is what Python is good for, is writing a program that does the same thing without fail, without flaw, exactly the same way over and over again. That's what Python's good for, and it helps to have a solid foundation in just problem solving and thinking like a coder. But we'll use it to wrangle, analyze, and visualize data. But in order to do that, you need to know the basics of coding. So we'll be covering Python basically throughout the course. And then as we're able, as time allows, and interest, and you guys have interest, I'll try and bring in some kind of one-off topics. I have a colleague that does a really good R programming workshop, so that you can kind of see at a glance the difference between Python and R. there's almost nothing, I would say nothing that one language can do versus the other. It's really more a matter of comfort. Data scientists, no kidding, statisticians, and those folks tend to prefer R. Python is becoming more general. But then there's other terminology you might have heard out there. Big data, data mining, business intelligence, machine learning. No SQL, which if you're a database person is kind of the next type of database that you might learn. Big data structures like Hadoop. So we'll try and bring those kind of things in as time allows, and like I said, as I learn more about your environments and what you might want to learn about, and the availability of guest speakers. I can cover the basics of this sort of stuff, but I really like having people come into the class and speak that are working in that area. Okay, gonna go another minute or two before we take our first break. Everybody doing okay?
Yep.
All right.
Yep.
Hey, Zoom fatigue is a real thing. We will take regular breaks. Okay, so guys, here's how we're going to run the course. Week 0, what I called up there, was a couple of weeks ago. We needed to get rolling in order to secure grant funding that expired at the end of March. But we didn't cover any real content. So if you're just coming in today for the first time, you haven't missed a thing. The schedule is I'm trying to put it together into groups, but some of the stuff we will be covering, it'll span more than this, and you'll see that in the detailed weekly schedule that I publish. For the first few weeks, it'll be all about foundations. What is data analysis? What's the analytical life cycle? Who is who in the data world? What tools are available out there? We'll do some practical applications of statistics and charting and whatnot in Excel. Just introduce the concept of relational databases. But then there'll be some overlap, and then for a couple of weeks we'll focus purely on querying data with SQL. The particular tool that we'll use for that, I'll cover in the next couple of slides. Visualization fundamentals, which is all the charting graphs, but it's also words and colors and contrast and all of that human perception psychology. So we'll get into that, and we'll implement that primarily with Power BI, but really you do data visualization with everything. You can do it with Python draws graphs and lets you do presentations, and Excel can do that. But Power BI is the no kidding business intelligence dashboard tool. So we'll make sure we've got an understanding of how that goes. We'll take a break in the middle of class the week following the Memorial Day Monday. So if you needed some time off or wanted a break, I'm going to need a break by then, to take a little bit of time off. It'll be that week 9. And I'm concentrating on Python in week 10 through 12, but I will be jumping into Python prior to then. And getting up into the like I said, the basic coding skills, so that by the time we get out there to June, we'll be working more with the analytics and formatting and wrangling and visualizing data, with using the Python analytical libraries. There are ways to extend the functionality of the basic Python language that has just made it blow through the roof. And 13 and 14, I'm setting aside for guest speakers, advanced topics, catching up on things that maybe we put off. Could be some advanced Excel by chance. anything like that. And then we'll do a cumulative project that I'll talk a little bit more about later this morning, in the last couple of weeks. No new material and no expectations on your time other than to work on a full cradle to grave data analytics project. Okay, I've got 9:18. So when we come back from break, and I use Verizon cell phone time for timekeeping. So I've got 9:18. See everybody back at 9:30. And we'll take a little break. I got 9:30. Oh, the other thing was it Chase was saying? Chase, you're a guitar player too?
Yes, sir. I am.
All right. Yeah, I collect cheap guitars.
Yeah, I noticed your collection's a little bit larger than mine. So
Well, they're all cheap, man. Like that black and brown one right there, that was $99. It's a Squire Stratocaster. I think I paid, I don't know, 200 for that telly.
right,
The Les Paul might have been 4. These are all like Epiphone or Squire.
right.
That guitar, that Flying V there, that was my one
Splurge.
indulgence. Yeah,
Yeah.
it's a Hammer, Hamer. Back in the 80s, it's an American made, heavy metal. Man, I so wanted to be Eddie Van Halen when I was 19.
Yeah, man, absolutely.
But
I have the only electric guitar I have is a Squire, and I've had it since I was 16. So I did splurge on a acoustic Gibson Hummingbird at Guitar Center. It was, they call it their vintage is, probably just a excuse to slap on, about, $500 more, even though it's got some defects on it. But, it sounds great, but she's a little hard to play sometimes. But
there you go.
I love it. So
there you go. Yeah, I got that's a cheap Martin that I dropped. I was getting it out of the case and unlatched it and got distracted, and then came back and forgot I had unlatched the case, and I picked it up to go out to the picnic table or whatever, and I flung that thing and the back of it's the top is that really nice booming spruce wood that makes a Martin sound like a Martin, but the back of it's a man-made plastic thing. It shattered, and I glued it back together. So I said so many bad words. My wife said, "Well, you've always wanted to get a tailor." So I did. I splurged and got myself a inexpensive Mexican-made tailor. But none of you care about that. That's not data analysis. That's Chase and Don talking guitars. Anyway, that's when I'm not. That's my main hobby. I try not to put too many irons in the fire, but
right.
like anybody else, I got tools out in the garage and home improvement, and I'm on a couple acres here in North Little Rock, so there's always something to do. So enough about that. We were back to the software for the class. So everybody's gotten into the Canvas LMS, correct? Did everybody get their invitation? Laura, maybe not. Yeah. I need your work email so I can send that invitation to you. You can put it in the chat window, or I'm dwalker@acds.co. I don't know why there's no M at the end of CO. I keep forgetting to ask our director, Bill Yoder, how that happened. So yeah, we'll use the Canvas LMS, and that's a place where I can share documents without going through goofy permissions and whatnot like a Google Drive, and it's fairly organized. We're gonna try a discussion board and see how that works for you guys to collaborate and learn from each other and talk to each other. I was very encouraged to see you guys in the chat room getting acquainted. It's going to be a long 4 months, guys, and I would say half the value of this class is reinforcing from each other how this stuff works out there in industry, and that it's not just a theoretical thing. It's not just like I think it was Thomas, who I'm not seeing. Did we lose Thomas?
I see me.
Ah, there you are. Yeah, man, I got the attention of all right. Thomas, you were telling me that a lot of what you were doing was really focused at was it Simmons?
Stevens.
Stevens. And that happens, guys. You work for in an area, in a company for a while, and until you get into, a user group or a cohort like this, it can seem like that's the only way things are done or whatever, it's easy to focus on the way we do it. So I'm hoping you guys will interact a lot and learn from each other, lean on each other, so anyway. The next tool, of course, Microsoft Office, mainly Excel and PowerPoint. Power BI, I guess you could kind of consider it's an extension of Office, or it interfaces with Office pretty well. But anyway, Excel and PowerPoint. And as a backup to our SQL lessons, if for whatever reason you can't get that fourth tool, SQL Workbench, working, you can do SQL in Access. So that'll be our fallback. Will be Microsoft Access as part of the Office suite. I think Python's up to 3.8, but it's the Anaconda distribution, and we'll get going with that next week sometime. So if you just Google download Anaconda Python, the distribution's out there. It installs just like any other program on your computer. So we'll. Is anybody having particular problems with downloading Python, or any questions on that? Okay, MySQL Workbench is the same way. If you just Google MySQL Workbench download, you don't need to install. MySQL is an open source database that it's enormously popular. It operates in the same space as Oracle or Microsoft SQL Server or PostgreSQL. It's spelled PostgreSQL, but people just call it Postgres. So there's other relational databases out there that you can use, but we'll use MySQL Workbench to connect actually to a MySQL database on Amazon Web Services that a guy hosts for me for next to nothing. And like I said, as a backup, we can always use Access. It does pretty much the same thing, but MySQL Workbench is a little cleaner because all it is like for working with queries. Whereas Access, that's made to do reporting and data entry screens and on a desktop. So anyway, yeah, MySQL Workbench is an application you install on your computer, but then I'll give you the the IP address and a username and password and whatnot so that you can create your own tables within your own table space, your own schema on MySQL. And then Microsoft Power BI Desktop, the free version out there. It doesn't work on a Mac. Was that you, Chase?
Yes, it's available on the App Store for iPads, but I didn't see a desktop version. I Googled all over the place, but I didn't see anything.
No, you can't. It's one of those things that I don't know if it's between Microsoft and Apple, or if it's more or less complex than that. But you need to use the workaround that so many Mac users use, which is to run a PC virtually, either through remote control software or spinning up a virtual PC in the cloud, and you run it there using your Mac almost as like a terminal into it. It may be worth like borrowing a laptop for a PC if you can, if work by chance can provide that for you. Worst case, if by chance is Waco or are they using Tableau instead of Power BI for anything?
We're usually We're using a data studio.
Okay. Well, rather than try and force fit Power BI into you, if that's not in your future, you guys, we will discuss this stuff generically. You know, there will be a few hands-on exercises, but this isn't like a huge showstopper. For the final project that I want you to do a no kidding cradle to grave, and then do a presentation. If you intend to present it using traditional visualization software like an alternative to Power BI or Tableau, those are the two big guys. What's the one that you guys are using at Waco?
Google Data Studio.
Oh, okay. There you go. Is that cloud-based or is that a desktop?
Yeah, it's cloud-based.
Cloud-based, yeah. So that's fine. Like I said, this class is to introduce the concepts, not to necessarily tie you or make you an expert in any one of these particular tools. But the underlying techniques are pretty broadly applicable. It's just you got to figure out, the language of that tool will be different, or the terminology and the the menus and all of that sort of stuff. But the overarching underlying theory will apply. So don't sweat Power BI if that's not doable for you guys at Waco and the Democrat Gazette. I know it was interesting. I think it was Laura talked about going from the paper to digital. My mother-in-law was, long-term Arkansan, third generation Arkansan here in North Little Rock. And they were taking her paper away and making her do an iPad. She's 80, 84. So this is a disruptive technology. This the digitization of information and being in the business, to me, it's natural. It's like, yeah, come on, bring it on, But my mother-in-law is 84, my mom's 87. Luckily, my mom checks email. She emails me every morning from down in Florida. But the digital revolution is definitely a banner disruptive marker in society. So anyway, that's the software we'll use. I did want to quickly stop sharing this. And oh, by the way, I record these sessions. I try and remember to pause them during the breaks and unpause them. But you will see that I am really absent-minded. If I'm not recording, if you don't see that I'm recording the session while we're in session, please don't hesitate to remind me to hit record for the group, for us all. But I wanted to real quick here, new share, go to my thought. Because I'm sharing Chrome now. Okay, does that look like a learning management system to you guys? Okay, so this is when you first pop into Canvas. Canvas is if you haven't been in college recently, it's a learning management system. Just a basic web page that lets instructors store materials and post assignments and discussion boards and those sorts of things. So I'll be using this to share files with you guys. When you first come in here, you're looking at the modules. Each one of these parent level things here is a module, and you can click on the little arrow and have them shrink. So so you'll see these modules basically follow the flow of the course as we talked about it. The only thing right now, what you're looking at, I exported from Blackboard the last time I did this course. I did it using University of Central Arkansas's Blackboard instance, I was the director of the Arkansas Coding Academy for a couple of years at UCA. It's a web development, full stack web development boot camp that helps folks retrain into programming. So I used UCA's Blackboard, and you can export Blackboard and import it into Canvas because it's just data, right? So of course it's going to flow smoothly between two major major systems. Not. So anyway, this foundations module is where I will be putting things. But I mean, you're welcome to comb through this if you're bored and or interested. But nothing in here is accurate until I tell you, hey, it's okay to go to this. Because I don't want to delete stuff from last time, but it may or may not be accurate, maybe out of place. Canvas has an annoying habit of it breaks a link if you don't tell it open in a new tab. When you click on that link that worked in Blackboard, it won't work in Canvas. So there's just little idiosyncrasies like that I need to deal with. But for now, under Foundations Overview, these are all the presentations I'm using today, and I'm hoping to get through here in the next hour and some. So that's Canvas, and like I said, Laura, I'll send you the invitation to that. It's pretty straightforward. Just pick a password and you'll have access. But there are things in here besides just links and files. Like we'll have this discussion question. I want to take the last hour of the day to take an inventory of business questions, plain English things that you want to know at work that we can then kind of all talk about and decompose and use as the framework to talk about the data that might address that and the type of analysis that may address that. So there's the discussion questions, and yeah, it's as easy as Facebook. You click here and reply and type up something, and then everybody else can see it. Okay, so that's Canvas. And I'm on email all the time, guys. So if you ever have any questions with any of this stuff or concerns, please let me know. Okay, so I will stop sharing that and go back to my presentation. Okay, so that was software. Exercises and final project. So as we're going through these different tools, particularly like Excel and Python, where it kind of helps to do a little practice. I'll post some exercises for you to do, but I'm going to try and stay within this 8-hour, twice a week, 4 hours a week. If you would like to practice more, or if it leads you down a path or whatever, great. But I'm going to try and respect your time and your employer's time, and keep your contribution to this effort between 8:30 and 12:30 twice a week. So we'll do small scale exercises. Open up this Excel file and choose the right kind of chart to do it, and then we'll turn that in and I'll take a look at it. And like I said, there's no grading on this. If you guys stick with me and are in the class, it's pass fail. But we'll do a cumulative exercise, and I chose the word exercise carefully so that it wouldn't get confused with a cumulative or final project. The cumulative exercise that I want to do, I want to I've got a project in mind. I haven't written down instructions yet because it's multi-part, but what I would like to do is for you to assemble a data set in Excel, and then add things to it that you're getting from different areas. So it would and then run some analysis on those columns in that spreadsheet, both single variable things and then, two variables looking at how things might correlate. So this is something that we didn't do last time that some of the guys suggested would be useful. And I'll go into more detail on this as we start to work on it. But yeah, so what I'm thinking was assembling a spreadsheet. I saw this in a tutorial I took one time where the instructor had assembled basically a 50-row spreadsheet about each of the United States, and then had columns that were different things about that state. Population, average age, when it joined the union, geographic size, how much money it spent last year on education or whatever, what the tax rate was. So there's all these different things. You could assemble a 50-row, 500-column data set about the different United States. But I was thinking it would be, kind of fun, kind of interesting if you guys chose, 4, 5, 6, 7, whatever, different things about each state, but then used Excel to kind of go out there and find that list on Wikipedia or wherever Statista or wherever, and then kind of cut it into Excel and go through that painful process of assembling data, so that you wind up with basically a clean data set that we can then use what we're learning on, statistics and charting and storytelling and whatnot to do kind of a cumulative project. So I thought about, on the final work related project, I want that to be work, but for this one, I wanted it to be something interesting. So if there are certain parts of life in America that interest you, whether it's education or childcare or tax rates or anything like that, or tourism, whatever the case may be, you could assemble that data and ask some questions of it, and we'll go through kind of an entire data analysis exercise with that data set. And if that's not sounding very interesting, and you want to do something that's maybe, if you're into investing, and you want to do like, the Fortune 100 companies and start kind of assembling data about them, I would like it to be something that you can't just go grab the spreadsheet and start working, because there is some utility in going through the pain of assembling those columns and cleaning things and making sure it's right. Hopefully not fat fingering data in, but sometimes you have to do that. You almost have to, it seems like. So that's what I wanted to do for a cumulative exercise, so that you would take those individual worksheets or comma separated value files, assemble them in Excel, and we would do some stuff with that. But then also take that data set, load it into SQL, and run some queries against it. And you'll kind of start to see how these different tools can do different things with the same data. And then in Python, there's utility in taking those disparate chunks of data and assembling them into, Python calls a spreadsheet. Python and R call it a data frame, which looks just like a spreadsheet, columns and rows. But using Python to open them and add them, it's not a whole lot of code, but I thought that might be kind of interesting. And then in Power BI, you could open up the same data set and do some different charts. So like I said, I wanted to do it something fairly easy. I didn't want that to be, super arduous as far as assembling a data set that we can use across all this. But we'll also have little exercises, of course, in these things. So that's the cumulative exercise I had. If there's another area or another kind of type of thing like that, hit me up. I'm not set on that. I just wanted to come up with something that I thought might be interesting to use as our kind of ongoing hands-on homework, so that you wouldn't have to relearn the data set that you're working with for these exercises. And then we'll do a work-related final project presentation out in July. So if you could start thinking about, especially you guys that are lucky enough to have more than one employee, start thinking about a project. You can work as a team or you can work as individuals. It's totally up to you. Doesn't matter at all to me. But work with your boss. Work together to think of something that you would like to do that would actually have some impact at work. It might answer a question that they've been wondering, but the data is so hard to get to that they haven't taken the time to actually answer it. It could be that you're maturing and documenting a particular analytical pipeline at work that hasn't been done before, or it could be something completely routine. Okay? It's really, like I said, this course is all about being useful to you guys at work. So those are how we'll approach exercises and the final project. Okay, I'm going to pause briefly. Questions, concerns?
Hey, Don, this is Erica.
Yes, sir.
Lindsay and I may not, the work that we do is a lot of the data and stuff is pretty confidential. So I'm wondering if there's a workaround or something that we may be able to do with the final presentation that's work related.
Well, Erica, thank you so much for that segue into my next slide. A note about confidentiality. Yeah, this is a topic that I need to talk about. So, the first one, academic freedom and non-attribution, that's something I learned about in the training and education world years ago, so that a speaker is free to tell you what they think about a particular topic. Well, that could be learning foreign policy in the United States Army Command and General Staff College, like I attended, or Air Force Officer Training School or whatever. So not to limit the bounds of appropriate behavior, but opinions should probably stay in the class. That, I guess that's what that means. If somebody might make a comment about their employer that might be seen as disparaging. We're all adults here. Just try and keep comments like that non-attributed to the person that might have accidentally said something they wish they could pull back in. Again, not at all addressing inappropriate behavior, but maybe particular views about something that may be slightly controversial. So just kind of keep that in mind here when we're working together. You all need to protect your organization's proprietary data or private data or sensitive data. So exactly, was that Erica or Lindsay that just spoke up?
It was Erica, but
Erica.
It kind of goes for Lindsay too, because we both work in cybersecurity. So.
Exactly. Yeah. And I was working with Cody and several GSK cyber folks last time. And it absolutely, the data itself, you can't expose network usernames, which could be attributed to actual human beings. But not only that, in your world, you need to be sensitive to transmitting what could be seen as vulnerabilities on the network. So the cybersecurity folks have a particular tough call. Now, what I did last time that I don't think they ever really took advantage of it, but I had a GSK only tour of the cyber range at UCA, which is a cyber range is just a giant computer that can emulate like the entire internet, and it can generate network traffic that you would be able to pick up from log files from different devices, proxy servers and firewalls and intrusion detection systems and those sorts of things. And it can generate that content that you could then use in a training environment. But do you guys know who Cody Villar is? Or any of the other three that were in the last?
I don't personally. I don't know if Lindsay does, but I did not.
I know Cody. Yes.
Okay. If you guys could get together with Cody sooner than later, and just kind of talk about that issue, particularly because you are in cybersecurity, you may want to do something that's a little more open source, or you may want to use dummy data. If there's a particular type of network traffic that I can help get simulated for you, or that we provided to that group, Cody would remember. I don't have that same email anymore. That was when I worked for University of Central Arkansas. But we'll address that over the next 4 months, so that you guys have a capstone project that is useful. But it could be that you guys go through this, but you work with your bosses, your supervisors. It could be that you just mask the findings, and that goes for any of you. It could be in this final project that you're asking a business question and you're willing to tell everybody a certain level of detail as to what you found when we do these final presentations, but there may be some things that are sensitive or proprietary or whatever, that you don't want to go into, and that will be absolutely fine. And then, whenever we're showing data, I'm going to use just data from, academic, from books and exercises and whatnot. But when you guys are using data, just make sure you protect for all the various laws, HIPAA, FERPA, PII, Privacy Act. There's any number of things. Generally, though, when you're working with data, you might have access to the raw, personally identifiable information, or even like, to the organization. But a lot of times it that gets dropped out in the analysis, in the aggregate. So anyway, yes, confidentiality is definitely something to be aware of in this environment. And let me know if there's if you need any help with workaround or dummy data or ideas in how to approach this. Could be that you don't use your own data at all. Could be that you do some sort of analysis of the industry vertical that you're in. But start thinking about it, because out there towards the end of July, we'll have a final day, and it'll be final presentation, and that'll be the final thing. A little bit about my approach to this course and teaching in general. Generally speaking, I don't know that I've ever run into a time when all of you weren't smarter than me. You know what I mean? Somebody out there knows more about a topic that I'll be covering than I do, most of the time. And in a group like this, particularly, a few of you have, I think Damon, you had a minor in data analytics. Laura, you just finished a Udacity nano degree, which I'm highly intrigued by. Priyanka, I know your background's heavy in analysis, or your current master's you're working on. So I don't expect that that I know more than all of you. But I'll keep the train on the track. You know what I mean? I'll keep things working, and I'll bring in experts. And if there's ever anything that we touch on, because I'm gonna try and stay kind of at the same level with all these topics. You know what I mean? I don't want to go railing into, theoretical, you know, 5-dimensional statistical anomalies of a parallel universe or anything, nuts like that. I just made that up, by the way. I don't even know if that exists, but I don't want to go into too much detail in any one topic. But if we do touch on something that you'd like more help on, let me know. I got lots of pretty good professional network and access to resources and whatnot. And if it's something that everybody sounds interested in, I'll try and put something together. But yeah, I'm not the in-depth expert on any of this stuff. Which leads me to point number 2. You guys have the potential to add as much or more to this course, talking to each other and sharing your experience as I do, and it's collaborative. When I come off the mic and I'm doing some of these lessons, and I ask, so how does this apply to you at work? We're talking about, the difference between mean, median, and mode, and how that applies to data that you work with. If I get to the question and then come off the mic and nobody says anything, it's going to be a long 4 months, guys. So hopefully you'll be willing to collaborate and share, and I won't be the only one talking for 4 months. Repeating myself here, the cohort adds as much or more as I do. I believe that I have learned in my role as a college professor and technical trainer. I've been an OJT trainer when I was in electronics. I had, once I became a journeyman, they assign you apprentices, and you have to train them. So I've been a hands-on OJT trainer, classroom trainer. I think it solidifies my understanding of the subject, because if I start to explain something to you and I confuse you, then that means that I probably don't know it very well. I've heard Einstein being credited with, if you can't explain it to your grandmother, you don't really know what you're talking about. So it forces you, when you're in a teaching role, it forces you to learn something to the point where you can make it intuitive or simple to the person you're talking to. And that will, as analysts, you guys are going to run into this all the time, where you're talking to somebody with domain experience, but they're going to ask you, well, where'd you get those numbers from? How does that graph work? And as you grow in this role, you're going to need to be able to explain things to them, or explain why we need time to automate this in Python versus doing it in Excel, and kind of, making complex things simple for your management. You will often stump me, and that's intimidating as a teacher. You want to know everything. Well, I don't know everything. The more I do this line of work, the more I find I don't know. I feel like I get dumber every day, because I'll learn about some new topic that's like sticking your head in a circus tent, and you find out there's this whole world that you didn't know about. Okay. Almost done with this presentation. We'll take another break. Okay, so yeah, you've seen Canvas. I'll post materials there. Don't rely on it being there until I've said, until it's the day of kind of thing, and I'll tell you where I'm putting it. I'll record like I am now. I did hit record, right?
Yeah, it's recording.
Yes. Whew, good. I hate that. It's just I wish it would just read my mind, but anyway. I'll record and I'll upload it to YouTube and put it in Canvas. it could, some of my college students actually prefer to just go to my YouTube channel and find the stuff there if they need to watch it. So I'll put it in both places. I link to the YouTube video in Canvas. 10 to 15-minute break every hour. So, you know, we start at the half hour, at the quarter after the next hour. Everybody needs a break. You know, pull the head earphones out, get up, stretch. Hopefully you're not stuck to your computer answering emails when you're on your break and never getting away from your computer. I think the pandemic has taught us that, you know, there's only so much of this you can take without a break. And for this distance learning, these Zoom meetings force us into, you know, staring at the screen versus turning around and talking to our coworker like we might have. So on the break, yeah, I encourage you to get up, stretch. And at any time, guys, it's just us here. Interrupt if you have questions, concerns. If my audio, you know, goes goofy and you didn't quite hear and it's something you want me to go over again, at any point in time, interrupt with questions. And by the method of your choosing, I like to come off mute and say, hey, hello. But that's because these things have raise hand in so many different. See, I don't even know where the raise hand is in Zoom. But you're welcome to raise your hand. Okay, so that's the course overview. That is left over from last time. Cut and paste error. Any course overview questions before we go on break? And actually, when we come back, we'll start talking about data.
What is your YouTube channel?
I think it's my if you would find it on my Gmail, Dr. Donald S. Walker, Dr. Donald S. Walker at gmail.com. But I think I can go onto YouTube and find a link to it. I'll do that. Any other questions, concerns? Okay, I've got 10:12. Come back at cell phone time 10:30 and we'll reconvene. Resume recording. All right. So I wanted to go over this one as well because I would like to use the last half hour, 45 minutes for the discussion board that I showed you in Canvas, which is talking about the business question. So here, this is just another scene setting presentation, but we're going to start talking about data now. Importance, what the career field is looking like, the data analytics lifecycle and maturity model for sure, because that shapes what some of you are doing and what you have said you wanted to be involved with in work, and how you want the course to impact you. And then I wanted to go over some industry terms to kind of just frame our discussion. Okay, so this is a slide I use in some of my college courses. Seems like this might have been back in like 17 or so. These slides are in Canvas. It might be easier if you just click on this in Canvas to see this graphic. But it shows the amount of data that organizations, companies, governmental entities, we as people, as individuals, we're just overwhelmed with data. Just on a personal level, I've got files everywhere. I would love to get to a point where everything is in my Microsoft OneDrive, but I do have a really terrible fear of putting all my eggs in one basket and like losing my password and sorry or whatever. I lost a Google account one time. No, a blog. Yeah, a Google account. One of the colleges I worked for, the account was a Gmail account, kind of like my ACDS account is a Gmail account. And then they decided it's not a Gmail account anymore. We're going to go to Microsoft Exchange. So my as a Google credential, it ceased to be. And I had been writing this blog for 2 or 3 years, and I didn't back it up, and I lost it. So data management and the enormity of the data challenge is underlying what a lot of you guys are doing. Not always. Some companies keep it concise, keep it short and sweet, small enough that they don't get inundated like this. But certainly the larger companies that some of y'all work for, this graphic is representative of the challenge. It's just a lot of data from different sources in different formats coming at you at different speeds. And it's a pretty big challenge. So this is an IBM report, and again, the slides have some utility when I do use them, guys, because there will be links in the speaker notes of the PowerPoint that may provide some resources that you find useful. But it's just a huge role. The what you guys are stepping into. Some of you are getting deeper in the role. Some of you are introducing yourself to that side of work. But every company of every type, even a sole proprietorship, will find itself needing data analytics. From cleaning and categorizing and organizing data all the way through to monetizing it and figuring out how to do things better, cheaper, faster. And there's a quote out there: "Data science is the sexiest job of the 21st century." It's a lot. There's a lot of cachet with the term, particularly data science, but it gets thrown around a lot. And there are I get Indeed advertisements all the time. There are just no end of jobs in data science, data analytics, and every other thing that has the word data in front of it. It's just incredible. I wish I'd paid better attention when I got into database development back in the day. So roles on a data science team, these are different positions you may or may not run into at work. So I won't dwell on it. Many of you are, you have the word analyst in your career, in your job title, which can often actually mean something else. And then, like I said, the term data scientist gets thrown around a lot, but generally speaking, the data scientist is the person that's broadening the frontiers of the way we look at data, the way we view it, the models, the artificial intelligence, machine learning algorithms, those higher level things. But it gets, I've seen people just doing basic spreadsheeting that they get the moniker data scientist. So it happens. So it can mean a lot of things. But generally, that's the person with the no kidding, statistical heavy mathematical background that is making sure you're using valid approaches, valid models. The data engineer, this is getting to be huge. A data engineer is kind of the person that creates the data pipeline. It's not the database administrator that gives you your Oracle account. It's not necessarily an SQL developer that makes a web application work because it can talk to the database and bring data back and forth from the database to the web page. A data engineer is the guy that or gal that creates the pipeline, the procedures, the discipline in getting data from point A to point B so that it can be used for analysis or other purposes, like using Microsoft SQL Server SSIS information services, SQL Server information services, to pull data from multiple tables and different databases, do transformation, and then stick it in a data warehouse where it's cleaned up, it's reliable, it can be used by analysts and managers and business intelligence folks to actually make decisions. Machine learning engineer. Machine learning is there's basically two overarching families of machine learning, supervised and unsupervised. Supervised machine learning is you feed data into an algorithm, and each thing will have a label. One of the classic examples of this that we're all seeing is fraud protection on your credit card. Every credit card transaction has um, uh, columns about it, has attributes. The how long it's been since your last transaction, how far you are physically since the last transaction, the amount of the transaction, the type of the business that is conducting the transaction, and then you'll have a label at the end, fraud or not fraud. And you feed that training data where you know whether a transaction was fraudulent or not. You feed that into a machine learning algorithm, and it goes, I understand there's a big correlation between between distance and time and the type of business and whatnot, and all those different factors. It can be many, but they all determine a label at the end, whether it's fraud or not. And then you train that algorithm, and now when you give it a live transaction, it's got a better idea of what's fraud or not fraud. So that's supervised learning. Unsupervised learning is where you don't have a label as to what anything is. You just have the columns, and you can start looking at the way those columns relate using what are called clustering algorithms. We'll get into this a little bit. It's fairly advanced. I certainly would need to get a machine learning guest speaker to come in and show us that. I've got a colleague at UCA that does this sort of stuff in R. But you'll hear about data mining. That's one of the techniques they use for data mining is this unsupervised machine learning, where it just starts to look for patterns in the data, so that you can go, gee, I didn't realize that someone's age had something to do with whether or not they play tennis or whatever the case may be. It all depends on your data and what information you have in your data. A data architect is or enterprise architect. Sometimes you'll see that word. That's really the person that's laying out how your entire organization forms its data. They're not generally the person that's hands-on moving the data around. They're not necessarily doing queries or doing an analysis or anything like that. They're kind of developing the blueprint of how the data is laid out across your entire organization. And then you'll often be speaking with business analysts / domain experts, people that know the business side, but they don't know analysis. And you'll be working with those folks mainly to tease out requirements. So you'll need to talk to them kind of like you would like a when you go to Home Depot and you want a new kitchen, and they start asking you questions about, well, do you want the sink on the left or the right? Do you need two sinks? Do you need one sink? Do you want the range hood? And they start asking you questions about what you need. Well, you will be that's part of your analysis. Often, I have found is working with the consumers of that analysis, like in management. To figure out exactly what they want to know, and then you run off and you do the data analytics life cycle to answer that question. And then your good old fashioned software engineer, that's your coder. Some of you are in organizations that are big enough to have developers, where you can actually talk to someone who's doing Java, or C# is another web-based language. They may be doing it in Python. I actually did talk to one employer that does their mobile application, the back end database and magic layer was done in Python. So it is a multifunctional language. But that's a software engineer is really more of a coder. They're not generally analysts looking at what the data is doing. They might know SQL and relational database design well enough to design a database, but they're not generally the ones pulling the data out of it and answering questions or anything like that. But you may be there to, depending on how your organization goes about it, you may be writing code, whether it's R or Python or something else, that gets managed kind of like software code gets managed, to make sure that people aren't overwriting each other's changes, and to make sure that it applies to a certain requirement. So there may be times when you work closely with a software engineer. And then this is just an interesting graphic about the different roles that you see out there in data analytics and data science. Across the top, you've got skills, communication, statistics, programming, and then business or domain experience. And then this Venn diagram shows you how they overlap with each other. Like a pure programmer, the hacker is a coder. Statistics guy is a data nerd, but he doesn't have necessarily any coding experience, and he doesn't necessarily have any domain experience. So anyway, I like this one over here. Communication with none of the other skills is hot air. And the intersection at the intersection of communication and business is a salesperson, but the perfect data scientist is in the middle there, of these four skill areas. Data scientist, analyst, depending on how potato, tomato. And then traits of a science data scientist. You're starting to see this out there. What makes a good analyst? There is some level of math, math and statistics. You got to be fairly technical. You got to know R, SQL, Python. There's just no way to avoid that side of it. But then you notice that business strategy acumen. No data analysis project starts without having a good reason, and the more that the analyst knows about the business domain, the more familiar they'll be with the data, the more things will leap out at them, the better they'll be at working with and the consumers of the analysis, to make sure that they're answering the pertinent questions and not leaving something out. When somebody asks you, "Where'd you get that data?" you'll be able to answer the question in their terminology. And then this is something I want to focus on repeatedly throughout the course. Starting at the top, which it should be labeled 1. It looks like you can start anywhere in this circle and jump in, but really any analytical project, and just for training purposes and the classroom purposes, I want to sort of follow this with your cumulative project that we talked about, and your work-related, cumulative exercise and your work-related final project, so that you can think about things this way, and you can report to your employers and in class here to us, using these steps and framing things in your mind about these steps. And I'll frequently refer back to the concepts here as we're doing things, just to make sure that it stays in the proper context. But the objective, if it's a data analytics project, the objective will be to answer a question. This is any cyclical process like this is going to be, they're similar. There's similar processes like this for process improvement, business reengineering, software development, certainly. But for data analytics, the objective should be to answer some question. Answer a question. And it could be mundane, and it could be something you repeat every morning. How many whatchamacallits came in last night? How many trucks unloaded? What's our current capacity of the overnight production cycle at the dairy or whatever? It could be very mundane, and not take up a whole lot of your time to get something running perpetually that answers that business question. But it could be something that's more of a one-off. It could be something that feeds a data analysis project that feeds something as critical as a board of directors decision to purchase another company, or to split your company into two, based on the results of this analysis. So this model fits the tactical to the most strategic. But that's you've got to start with an objective. Why are you doing what you're doing? What's the point? What's the question that you'll be answering? And once you've got that, in the software engineering world, it would be your requirement. What is your requirement? And then you move into action. Understanding the data would be looking at that business question and then thinking about what data you have on hand that can answer that question, and where is it, and what format is it in, and the overall layout, the data environment, how clean is that data? I mean, there's a lot of factors that you will go into to understand the nature of the data that affects that or answers that objective. Then you would move into cleaning and data transformation. That's where you actually pull the data together from its various sources, and make sure that you don't have null values, blank lines, if it's spreadsheet data or Python data frame data. There's just a lot of different things that you could do in that step. Classically, whenever you look into this, and somewhat to my own experience, confirms it's about 3/4 of the time that you spend is pulling data together. My 1 year in the trenches doing data analysis was about 15 years ago, and it was in the Air Force, and I was pulling together data from different functional support systems that support the deployment of our troops overseas. Like back before 9/11, we had people rotating in and out of Iraq and Kuwait and whatnot, or I'm sorry, Turkey and Kuwait, every 90 days in the Air Force, and jets and equipment and everything. And there were about 6 systems that addressed, where we need people and who's ready to go, and whether or not they've been ordered to go, and all those sorts of things. So I was pulling data from those different systems, and there was a whole lot of Excel going in and grabbing the first 2 characters here, because that's all that really matters, and kind of changing formats, making sure somebody hadn't fat fingered in something, because not every application that provides your data will error check necessarily, ideally, and you'll wind up, as the analyst, you'll wind up compensating for those shortcomings. But I mean, in a perfect world, this data cleaning and transformation can be done in the creation of a data warehouse that the analyst just gets to write queries against, and you can trust everything in the data warehouse. It's because it's already been error proofed and whatnot. But that rarely happens, to have a fully trustable, mature data warehouse. And then data enhancement, to me, those two are combined. I've seen other models that only have the 5 bullets, so I would put that in with the other one. But then it's performing the analytics. Now you've got your objective, you've got clean data. Now you got to perform the analytics, which includes choosing exactly how you measure that. If you're doing something that has something to do with inferential statistics and confidence intervals and those sorts of things, or if it's just plain old reporting exactly what you see, you actually perform the analysis and start to derive meaning from it. And then the final there is visualization, but I would say communication would probably be more general and more accurate. And we will do this. We will run through this whole cycle, and the final product is communicating what your analysis shows. If it was a predictive question, it might have just been something that was reporting what happened. It could be asking for a prediction. You have to, in that data visualization, you have to explain the results of your analysis, and that could be through charts and graphs, but it's also words. There's a lot of data storytelling in there. It could be justifying where the numbers came from. That there may be, depending on who is looking at your analysis, you may have, people asking you, where'd you get those numbers? Because I don't like that, and you might need to weave that into your communication, your reporting at the end. And then some of you are helping move your organization up this analytics maturity model. That this comes from Gartner. There's many of them. We'll be doing a lot of the first one. What happened, looking at the data and just making sense of data that you have on the shelf. These are quarterly sales figures. These are the results of surveys, the grading that's been done in classes, whatever the case may be. How many people clicked on a link? How many folks accessed a shared drive, maybe that didn't have passwords? If you're in cybersecurity, looking at folks that are accessing parts of the network that maybe they're not necessarily supposed to be accessing, and that's all really descriptive analytics. But some of the stuff will move up towards diagnostics. Why did it happen? Predictive analytics is things like where you use like linear regression, and you have or logistical regression, and you have basically a mathematical formula that you could plug a number into that says, if we increase, selling on or funding of advertising, we can expect X ROI on income, say. There are predictive things like that. And then prescriptive, that starts to get into the fairly ethereal. If you can actually start to, how can we make it happen? Well, now you're talking business strategy and whatnot, and creativity. So I don't know how much we'll get to there. We got to get through we got to get through Python and Power BI and all of that. But anyway, that's the maturity model. That's where everybody's trying to get to. The higher up you go on this, you tend to see more artificial intelligence and machine learning, and breaking the boundaries of what a human can do, particularly in the world of, and I'll go to my next slide. That second bullet there, big data. Data science is, the tools and techniques for doing what we do, really. Big data is a buzzword that was created about 15 years ago, 2005 or so. And it refers to the tsunami of data that that we're presented with. The velocity, variety, and what's the third V of big data? Laura, you just went through one of these. Velocity, variety, and it's not veracity, although that's one of the 5 V's.
Volatility.
What's that?
Is it volatility?
Volatility. That might be it. I'd have to Google it. Anyway, big data comes at you from all these different sources. It's everything from credit card transactions, financial transactions, video surveillance that you can do object recognition in, and facial recognition, and social media posts, and all of that stuff from that previous slide. And the challenge of consuming it, transforming it, and making sense out of it. It's a growing field, and they're just getting started, and it's only getting worse. I think the challenge gets worse as we go on. You know what I mean? I think we're generating more and more and more and more and more data in different forms and everything faster than we know what to do with it. But we're gonna be concentrating on good old data analytics here, where you've got a data set and you're basically reporting the results of those, of that data. Data mining, again, is looking for patterns in the data that you don't necessarily go in with a question. You just let the data speak for itself, and there are tools and techniques that that can help out with that. A data warehouse, a lot of times, a data warehouse they use that metaphor, I think, very accurately. I mean, if you can think of, a well-run warehouse like an Amazon fulfillment center. I ordered my mom air conditioning filters Monday. They came the next day. The Amazon fulfillment center isn't far away, but it's managed such that they know exactly what they have, where it is, how long it's going to take to get it out, what format it's in, what shelf space to put it on. It's a very way of organizing thing, a very efficient, effective way of organizing things. And a data warehouse is a lot like that. You've got, the alternative to an Amazon fulfillment center is, the 7-Eleven and the Ace Hardware and the paint store and all these little, little mom and pop stores that all sell separate special things. And a data warehouse is kind of like that. It's a centralized repository that grabs things, kind of like a warehouseman grabs things from distributors, and puts them where they can be used effectively. So you would pull data from your financial system, from your customer resource management system, perhaps from your social media reviews and social media activity, things like that. And you would put all of those, all that data from these live support systems, and put it all in a central warehouse that is there. I would say purely, in theory, it's there purely for answering questions, for using something like Power BI or Tableau to do a dashboard against. So you set up this process where the data warehouse gets refreshed from these functional support systems at whatever rate makes sense. And the data warehouse may or may not be laid out, architected similarly to those functional support systems. It is there to answer all of the analytical questions that the organization might have. And you can start to to do a data warehouse at almost at the individual level on an Access database on your desktop. If it makes sense for you as an analyst to have these things pulled in and repeatedly formatted in a way that you don't have to, like, every morning go out and fetch things from all these different areas in order to do analysis. It's something that it takes work to get a data warehouse going, but once you do, it makes your analysis a lot faster, and it's pretty hard to do real-time data analysis like a no kidding real-time dashboard without that level of integrity in your data. And then business intelligence is decision quality information that allows managers to make decisions really in real time. That could be short term, like when it's time to let servers go home from Olive Garden, because our historical data tells us that once we've our number of transactions reach 12 per hour, that the density of customers is so low that it's time to cut staff down to 50% or whatever. It can be that. It can be looking into sales. It could be supply chain. I think Damon's got a background in supply chain, at where items are in the supply chain process, so that you can make decisions as to for just in time inventory, those sort of things. So BI it's a whole nother giant part of being an analyst, so that you can put that data out there and visualize it. Okay. So that's kind of foundational process level stuff I wanted to go over. Any questions on any of that terminology, or how it affects you? Any comments on where you fit into that and where your organization is aspiring? I'm not going away, guys. Somebody's going to have to come off mute and talk to me.
Guess I'll break the silence. You had mentioned that big data has been kind of a key word, and I can absolutely attest to that. We've got our, executive leadership team talking about how we want to do all this big data stuff, quote unquote. And then now we get into it and we're like, well, we have no idea what we're doing, kind of thing, So.
Yeah, it's a buzzword. It's like data science. We need to do data science. Well, what do you mean?
Right.
Yeah. So and big data particularly, there is absolutely no clear line for when you go from data to big data. Whether it's the volatility, the speed it's coming in, the quickness that it changes in, the difference in formats, how clean the data is, the type of the data. There's no clean line, but generally speaking, as far as the big, calling it big data, it's if it can't be processed on a desktop computer or on like a server, and there's software out there, because you're talking gigabytes per day or more. There's software out there. The two I'm most familiar with are Spark and Hadoop. These are server side things. A lot of times this is all done in the cloud, where you can set up multiple multiple instances and of computers that are all chopping on the same question, doing the same processing on similar data, and then kind of aggregating those results for truly huge data, like the Human Genome Project. You might have remember that maybe like 10 years ago, they cracked the genome by letting people's PCs actually work on deciphering little tiny parts of it all in parallel and then combining the results. There are big data frameworks like that, but to say we need to do big data without going back to here, what do you want to know? Well, there will be people that say, well, what's our data look like? Well, it looks like a bunch of numbers and letters. I mean, that's what data looks like. What do you want to know? And then you can start to see if you're even collecting the data that you need. Part of this, data enhancement is going, you know what? When a customer checks out, it would really help if we knew their phone number so that we could do a customer rewards project program or whatever. So the data enhancement looks at depending on what you're doing. It could be that your IT folks need to enhance the data that you're collecting. It could be they collect it a different way. It could be that they add a block to the website to collect a little bit of data from each customer. It could be that it does some figuring. Maybe the website does or doesn't do, I don't know, click analytics or whatever, and you want them to add that so you can see which parts of your website they're spending more time on, or anything like that. It can be data enhancement, so that as an analyst, you then have the data you need to answer that big objective question. See, somebody says, thank you, Andra. You talked for 20 seconds and you got me to fill up another 3 minutes. See, yeah, that's about the ratio that you guys can expect. Hey, Don, what time is it? Well, the clock was invented in 10th century England, originally made out of wood. It's a well-known fact. Any other questions on process, organizational, team level stuff while we're on it?
No, but I did have a question. I do see all these links that you have in the bottom. If I were to go onto Canvas and download these PowerPoints, would those links still be there?
Yes, ma'am. They're in the speaker notes. When you pull up PowerPoint, there's that line down at the bottom.
Mm-hmm.
And if you grab it and drag it, you'll see those notes.
Okay.
And the links are there. Okay.
Hey, Don, I got a question for you.
Sir.
All right. You mentioned that you were in the trenches of data analytics for about a year. I was just curious, did you, after that year was up, was it a voluntary change to a different focus, or just that particular instance only lasted a year for you?
Yeah, and a military career is going to be unlike, you don't drive your career.
Sure.
The military does, So what I was doing as an analyst, I was working in an analytical support cell for a one-star general that ran the Air Force's deployment process. And it's called a CAG, Commander's Action Group. And it wasn't in my core career field. It wasn't in IT. It's kind of like I was working with a missileer, a medical operations officer. We came from all these different career fields because there's very few people that actually do deployment, like personnel deployment. So they were using people from different career fields. Anyway, yeah, I left because I needed to get back into IT. So I moved from there to running a testing and integration laboratory.
Okay. Thank you.
I loved it though, and it's always been kind of part of who I am. I started off as a database developer, and it always seems like I'm turning back around to what's the data say, and even not necessarily structured data. There's text mining of like Google reviews, where it's much more qualitative, where you're analyzing whether or not a review is positive or negative, and what they might be recommending. Well, there's getting to be software that can go through those sorts of things. So I've always just been fascinated with data analytics.
All right.
All right. So we're coming up on another break, but I kind of want to power through and be done for the day and get you guys thinking about the objective. I want to stay on this screen for just a minute because there's a discussion board, and this is kind of an experiment. I would like for you guys to use the last, like I said, half hour of the class. You if you work together, you're welcome to work together as a team, or post individually if you don't work closely together. What are the objectives of your analytics? What are some business questions that you want to answer? And then I think I ask in Canvas, what's the data environment look like to address those questions? So we're talking about the first, half or so of this data analytics life cycle. And then I was hoping, like I see you guys doing in the chat room, I would hoping you would read each other's responses and reply, ask questions of each other, just kind of get to know each other, discussing what are you doing here? What are we doing here? What do you want to know? What sort of questions are you going to answer for you? And it may be, you may not post this afternoon. It may be that you want to go talk to your apprenticeship mentor, your trainer, and kind of bounce this around and then post some stuff. But that discussion board, I will read thoroughly, repeatedly, because it helps me frame everything else we're doing. So please, even if it's not necessarily before 12:30 today, sometime before we come back to class on Thursday morning, please post what you can, and you can brainstorm, just fire away, and I'll take a look at them, and we'll all look at each other's and sort of start to think, and it kind of helps us all understand what what sort of business questions each other are driving after. So I did want to stop sharing that. Stop share. Stop share. And put that one away. And I wanted to talk about the tools of the trade real quickly. And then we'll head back into project mode. Again, ideally, I only want you guys to spend the 8 hours that we've agreed to. On this. Okay. So here are some of the tools of the trade I wanted to go over, just to, again, scene setting, analytical personality traits, and then the no kidding tools, particularly the ones that we'll be using here. And these are things I pulled offline that jive with what I've seen. Inquisitive, quantitative mind. Whenever you're watching TV, I'll bet those of you that are have an analytical mind, you want to know, how'd you get that data? Who says who? How'd you get that number? Where did that come from? You start to kind of want things to be quantified, as opposed to just going by gut impressions. It really helps working with numbers and really solving problems. For me, that's the software engineer side of me, going through requirements and design and coding and implementing software systems. It's good to have intellectual balance, or that can skew your results, or potentially skew your credibility if you are looking for data that supports your position versus reporting what the data has to say. And this is particular in in no kidding research. where you are developing a hypothesis, gathering data, and reporting whether or not your hypothesis was proven. But you strive to avoid researcher bias. You certainly got to be persistent, especially like, when you're coding something up or trying to get one of these pieces of software to work. It can be frustrating. So you definitely got to stay at it. And it helps to be communicative. Like I said, you'll be working with consumers of data. So helping them understand, what data you do have on hand and what you might be able to help with and what they need, what are their burning questions, but then as you report the results of that, you need to be communicative. So I think communication is an important skill. And what other factors are you guys seeing? You got any particular mentors out there, or folks you've worked with that inspired you? Looking for other traits.
Naturally skeptical.
Skeptical. That's a good description. What in your view, what does that mean?
It made me think of it when he said asking how and why and how you got those numbers, and not just taking somebody's word for it.
There you go. I think so. Anybody else?
Another one might be patient. It might kind of fall in line with persistent, though.
I think you're right, Damon. What were you thinking of that has tested your patience recently?
Well, I guess art can be kind of frustrating sometimes, because when you're coding, if you leave off just one little thing, or something's out of place, the line of code won't run, and sometimes the errors aren't super clear, So in those instances, it's kind of good to take a breath, I guess, and be patient with it.
Sure. And in that particular example, I think being communicative helps as well. A lot of times data analysts are working alone. You can confirm or deny this, Damon, but you're working on that R code alone. You're not working in an R development shop where you're working side by side with other folks that are working in R that can necessarily come and help you. And
yeah, that's correct.
Yeah. And like in a big company, like we do some work with JB Hunt. When I was running the coding academy, we got several people hired up there at JB Hunt, and you're sitting on a floor full of web programmers. There are processes where you will look at each other's code, and you always have somebody to go, hey man, I can't get this stupid thing to run. What am I doing wrong here? And I've noticed that analysts a lot of times don't have that, not as freely available, support structure like a no kidding software development shop. So, yep, patience, persistence, communication.
I think having a good imagination would also probably help to be able to see, maybe ask yourself, what in the future could this turn into? Sure.
Yeah, and imagination. That made my mind immediately click over to creativity. I think a good storyteller, a good data visualization storyteller, has to have a good imagination, and kind of be thinking of what the audience, see it through the audience's eyes when they're creating a presentation, and be kind of artistic and creative like that. I'm not, so I really enjoy it when I see other people that have a knack for that. You've seen my PowerPoints, how creative and artistic I am. If it's got the information on there, it's good enough, right? So that's, yeah, traits of a data. So the next tool, statistics. So you've got the collection, organization, interpretation of data, so, which is huge. I mean, and a buddy of mine had trouble with inferential statistics, and he used to call it sadistics because it was sadistically cruel. So I thought I'd give him a shout out. But it's all of that. Yeah, it's looking at the data and interpreting the data. If you've never had Stats 101, that's fine. We'll get through all of this in with minimal pain. I have found that I worked, like I said, I worked as an analyst, and I was reporting the results of troop movements over to the Middle East. I don't know that I ever used statistics. I was reporting the results of the data. Who's over there? Who's next? Who's ready? Who's not ready? Who has equipment on order? What equipment do they need? What's the most demanded skill, which is kind of aggregating data and everything, but it's not really statistics. You know what I mean? Like you would think. So you can do a lot of this stuff without a whole lot of statistical theory, but we'll go over these two categories to some depth. Descriptive is looking at basically one variable. And it describes the characteristics of a particular sample or the population without drawing any necessarily conclusions as to whether or not that chunk of data you have represents what the larger population did. Think about political polls when they go around and they ask, are you going to vote? Who are you going to vote for? Yada, yada. They take a sample. Well, descriptive statistics would tell you what that sample says. But inferential statistics looks at the nature of that data and how scattered it is, how diffused it is, and whether or not you can draw conclusions, whether you can infer those results of that sample that you took to a larger population, which is where you start getting into a bunch of stuff I don't work with frequently. Confidence intervals. There's some probability theory in there, but like I said, I got a PhD. No, not me personally. I know a PhD that does a really good workshop, but you know how like COVID happens? Well, she's going to have a baby pretty soon here. So we'll see if I got to go get a different statistics professor to work with us mainly on inferential. The descriptive stuff you'll start to see that you've probably worked with or heard of and whatnot. But those are pretty heavy tools when you look at all these data science, data analytics job descriptions out there. Everybody is still using Excel. Came out in '85 and still going strong. Most folks I know that are in the biz say it can do almost anything right up until it can't. And you start particularly with large data sets and sharing data. That's when I think Excel starts to run into problems. But I still see it on all these job postings. I still see knowledge of Excel at the very top. Excel can be used to, I don't know if you've ever at work, you've ever had somebody create like an entire program. At UCA, we would do our travel vouchers in Excel and turn it in as an Excel file, which brings in all kinds of weirdness when you're trying to format an Excel spreadsheet to be a pretty data entry screen. It just starts to show its weakness. So you can create an entire application where you're entering things and Excel is interactively, giving you answers and whatnot, in Excel. But I'm not going to go that far with it. I want to use Excel to work with good old fashioned tabular data where you've got headings across the top and rows of data, and we'll be working on it to do formatting and using the built-in charts and working with formulas to convert data and figure things out, from between two periods of time. What was the change in whatever revenue or whatever, those sorts of things like you would expect. I don't want to get into creating applications with Excel. A lot of companies are really trying to get away from those applications and get to something closer to a Power BI dashboard. So the next tool we'll be covering, structured query language, is a very easy English sounding language. If you're cool, you call it SQL. Somewhere along the line, I learned SQL in 1988, so I've been working with it forever. But I guess I worked with somebody that called it SQL, so I started calling it SQL. Anyway, either one goes, but it seems like, no kidding, in the workplace, it's SQL. And this is the tool for working in a relational database. And like I said, it's an ANSI standard language, but every database provider has extended it somewhat. But generally speaking, once you understand relational database design and how these queries work, you very little problem switching over between the different database providers out there. And we're going to look at it for querying, which is called a select statement. You can write a query that would be like, select last name, comma, first name from personnel table where department equals finance. And it spits out last columns of last names and first names where they work in the finance department. It's very intuitive. Where it can get to be challenging is when you have related data in different tables, but we'll go into all that. We're going to spend a couple of weeks on SQL. But it can also be used. SQL is also how you create tables and how you update rows in a table, how you add users, how you commit changes or roll back changes to the database. When I was working in an Oracle, you'd log into Oracle and you get this SQL prompt, and everything you do in Oracle, period, including usernames and passwords and permissions and whether or not certain users have access to a table or a view or not. It's all done at the SQL prompt. And then good old Python. I chose to learn Python a few years ago because it was being used not only for data analysis but also for web development, and they're teaching it in school to the kids and everything. And there's just so much support for it out there, that I made that choice, even though R is arguably being used. It's not as popular, but there's a more loyal following among, no kidding, data scientists, statisticians, that sort of thing. But it's free. First released in '90, but never heard of it until maybe 10 years ago. There's a term you might have heard called object-oriented programming. Don't get too intimidated by that, but we will have to learn a little bit about what that means because of the way the language works. If you are a coder, if you have programmed before, we won't be creating classes and creating objects, but since some of the classes like strings have methods, you have to know what a method is and an object method. So yeah, we'll have to cover it. But don't sweat it. But the big thing about Python is these libraries. There's this huge community of people that extend the functionality of Python such that there's almost nothing you can do that there isn't a special library for, like analyzing TCP/IP traffic. There are libraries that are made to open up a TCP/IP log file, datagrams, and automatically throws it into the individual fields in a TCP/IP datagram or an Ethernet frame or whatever the case may be. There are special libraries. Now, what we're only going to cover the 3 or 4 really famous, popular ones, like Pandas. Lets you work with data frames, and Matplotlib and Seaborn let you draw pretty graphs. And there's one that does machine learning called scikit-learn. We'll work with those. But I want to start from scratch. I want to make sure you guys can think like programmers, and you can understand data types and loops and those sorts of things. And it's not hard. It's not rocket science. It's just you're fortunate enough to be in a program where we'll go through it methodically, and it'll be fantastic. And here's another reason I chose to learn Python. This is I don't know if it was Stack Overflow. Yeah, based on Stack Overflow, which is arguably the biggest computer programmer support social network kind of thing, where you can ask questions and answer questions and talk about different techniques and whatnot. So according to Stack Overflow, look at our bold pink line there. Python's going through the roof as far as the number of topics that are being chatted about, the activity. Java runs kind of steady. JavaScript is a language that's used in virtually every website you ever go to, every web page. But then you can see kind of these declining, C#, PHP, but Python, you don't even see R on the map here, because R is contained more or less within the data science universe. So even though I put it in this presentation, I put it in quote, real data scientists are and pirates. I forgot I put that in there. Oh, R is the favorite programming language of pirates. Kill me, R. But it's a special purpose language. That's the thing about Python. It can be used to script and automate almost anything. It's a general purpose language. R is hyper focused on data analytics and statistics. So it doesn't have as broad based a support. It's also been out forever, and it is also free and with a huge community of people adding libraries and packages to that. And if you're not a computer programmer, a library is just kind of like functionality that you read into your program that gives you more commands that work, so that you don't have to write the code to do special things. And you'll know all about libraries by the time we're done. But then we got to have something to visualize with, right? And there's many of these. You can do data visualization in any of these tools. Well, not so much SQL, not so much SQL, but Power BI, SAP, SAS, Tableau, Excel, Python creates beautiful charts that you can save as a JPEG and throw into PowerPoint. And then there are data visualization, cloud-based data visualization. What was the Google tool?
It was called Data Studio.
Google Data Studio, yeah. And then I think Azure has SQL Server reporting services among other tools. It seems like there's Power BI in the cloud. I haven't looked into it. Anyway, there's all kinds of ways to accomplish the final step in your analytics project. It's kind of going to be up to your organization, you as an analyst, to decide which tool you want to use to present your results, and the format and the story that you will tell with that. Which tools are best? Well, there will be times in this course that you're thinking, this would be easier if we did this in the other one. Um, there's advantages and disadvantages to all of them. What jumps out like a SQL, that's inherent to the database. The queries run pretty quickly. If you're like logged into the database and doing things natively there, you will see that it's pretty powerful for pulling a data set out. You could write that query in Python and clean it up. You can pull. I've been working with a data frame in Python and thought, oh my goodness, this would be so much easier if I could just go out to the SQL prompt and ask that question. But the tool, what makes Python so good is that it will automate processes that you're doing manually. And if they are fairly clearly defined and you can come up with rules for what you're doing with these different files and columns and the facts and figures that you're creating, and you automate them in Python, you run it once and bam, it does it. Now you can also use Python interactively, like you can Excel, like you can SQL. But what really makes Python, maybe stronger than Excel in certain ways is its ability to automate stuff and run on a server in the background at midnight. Whereas, Excel macros can kind of do the same thing, but it's really more for a single user at the time that you're doing it, kind of, you know what I mean? So these tools are, they're tools in your toolbox. They may have a certain design, but depending on your preference, and how you go about using these, we'll cover them in the class, but as far as your future as an analyst, it's up to your organization and you as an analyst and your comfort level as to what portion of an analytical project you do any of this stuff. I know some folks do everything in R. They never even they're good enough in R that they don't even need to open Excel to clean things up. They can just do everything they want to do on that data set in R. So it all depends. So I don't know. I think maybe I might have gone slightly out of order. Actually, let's pick up here on Thursday morning. This is kind of a new topic. And I would like to give you guys the remainder of the day to go back to that discussion question in Canvas that we were talking about. Business questions. It's a project that starts with a business question. So if you guys have used the rest of the time to either think, or if you already know what you're gonna post, go ahead and just start popping some replies into that discussion board. And then we'll reconvene on Thursday with a little bit more foundational stuff, but then I think we're going to go ahead and move into statistics and types of data and chart types and all that kind of stuff, a little bit more hands-on on Thursday morning. Any questions, concerns, comments before we adjourn for the day? All right. I must be the most clear, concise, expressive, engaged trainer you've ever had then. I can see you smiling, Thomas. You're the only one with your camera enabled.
Yeah, I started to say, yeah, you're almost as good as my wife, but I wasn't sure how that'd fly.
How that would have come across.
Yeah.
All right, guys. Yeah. So only homework, project work is business questions. What is it you guys have been tasked with answering or addressing? And it can be pretty vague, pretty broad. But the more specific you can boil those down into actual questions, like that end with a question mark. Which team sold the most widgets last quarter? Anything like that. Now, you're welcome to put them in there, but if it's a strategic predictive analytics, how can we overtake the competition next quarter? I would say that we're not going to get there in this course as far as the level of analytics. So hopefully you've been tasked with addressing some fairly tactical level business questions that'll help us, think more about these data analytics projects. All right, no questions? Okay. If you haven't got your paperwork to Maria and Kelsey, appreciate you doing that. And I'm always available via email and or cell. I put my actual cell phone in my signature block in my email. We will reconvene at 8:30 on Thursday morning and dive a little deeper into the world of data analysis.
Great.
And I'm going to stop recording.